For most of us, this is what comes to mind when we think of a weather forecast.
Good chilly Wednesday morning, South Florida. As promised, temperatures have dropped as we have that.
What's the temperature? What are the chances of rain? Will it be windy? But for the world's working farmers, that's more than 1 billion people. The weather forecast carries a lot more weight. It affects their entire well-being.
If you plant too late, you can miss an opportunity to get a bunch of growth out of your crops. If you plant too early, you can put seeds in the ground that never get rained on and then die off before the rain actually arrives. So you have a pretty narrow window of time in which to plant your crops in order to ensure a productive season.
This is Fiona Burlig. She's an economist and an assistant professor at the University of Chicago. She studies how energy and the environment interact, particularly in developing countries. When Fiona talks about working farmers, she means essentially small family-run businesses, a couple of acres in places like rural India. And for those hundreds of millions of farmers, there is almost no tool more valuable than good information in the form of a high-quality weather forecast.
So, of course, there's a bunch of things about how the weather looks that will really matter for how well a farmer does in any given year, right? So one big thing is just how much does it rain? But it turns out that another thing that really matters is when does the growing season start?
But here's the thing. Because of climate change, weather is getting more extreme and more unpredictable, which means modern forecasts are becoming less and less useful.
There's massive amounts of risk that these farmers are taking on, so they're really facing this highly variable kind of production environment. They have to make these complex decisions under a massive amount of uncertainty.
So this...
Good chilly Wednesday morning, South Florida. As promised.
This good morning, chilly South Florida simply won't cut it anymore. These farmers' lives, and our lives, after all, they're exporting things like rice and wheat, depend on better forecasts. Luckily, there's a revolution happening right now. The kinds of complex forecasts that used to take millions of dollars and the most advanced computers in the world to generate can be personalized down to a small region on a single laptop. And the key to it all? AI. I'm Amy Harder, and this is Shocked. You've heard of the Farmer's Almanac. Well, this is the Farmer's A.I.manac. Climate change is disrupting food systems. Part of the problem is that climate makes weather more unpredictable. Like Fiona described, knowing when to put seeds in the ground matters, and the status quo is not good.
So as you can imagine, knowing when the rain is going to start is hugely important to everyone in the community. And so, people have tried a lot of different ways to try and figure this out. Back before we started the study properly, we just did a bunch of interviews and asked people how they got their information. One source of information that turned out to be really common was that the local astrologer becomes the most popular guy in the village around the time that people are trying to figure out when and what to plant. Turns out that guy doesn't have accurate information, but he tries, and people really want to know. Another source that people go to is the government. So the Indian government produces a series of weather forecasts. The main forecast they produce about the monsoon is something that they call monsoon onset over Kerala.
This is like trying to predict when it will rain in Connecticut by observing the weather in Miami.
And it doesn't necessarily tell you all that much about what you need to know as a farmer, which is when the rain is going to show up in your village. So really here, this is a hugely important piece of information, but farmers just don't have great access to it in the status quo. That's largely because this is really at the frontier of climate science. So the monsoon is a particularly complicated piece of climatology. We don't understand all that well how exactly it works.
I'm talking about India so much because, like we've said in other episodes, this is the nation at the nexus of so many climate and energy issues. And Telangana is particularly important.
You can think about Telangana as sort of one of the primary agricultural regions of India. India is an incredibly fertile agricultural country in general, produces a lot of food to serve both itself and the global population.
Telangana is a top producer of lemon, grapes, and mangoes, and a lot of rice. So what's the forecast that people are getting from the government based on? Why isn't it good enough? We did ask a climate scientist who confirms monsoons are really complicated.
So we know like an approximate state of the atmosphere, but we don't know the precise state of the atmosphere.
This is Pedram Hassanzadeh. He builds AI weather models. Pedram is a researcher in weather and artificial intelligence at the University of Chicago. He says producing high-quality weather data can cost hundreds of millions of dollars. The electricity alone to run the supercomputers that produce these forecasts costs millions of dollars. I asked Pedram to explain why the current world of forecasting is not working well for most of the world.
So weather forecasting is very expensive. It needs really good people, highly skilled, basically experts in computation, in computer science, in applied math, to work together to build a weather model.
And there are only a handful of places in the world with those kinds of resources. The US, Europe, China.
But there are not so many. It's not like every country has one because, again, these are very expensive. And of course, weather forecasting has huge societal value, right? Again, whether it's early warning, whether it's for airlines, for trucking company, everybody needs weather forecasts, right?
Instead, low-income countries have to rely on models that were designed for other countries. And North America, Europe, they have really different weather systems from places like India or Kenya. It's like having to wear hand-me-downs from someone who is not your size and lives in a completely different climate. For over 100 years, weather forecasts have been made using physics-based models.
Physics-based models also have a lot of knobs, and people have figured out how to basically calibrate these knobs over North America, over Europe, because this is how land and atmosphere interact and things like that. But then every time you want to calibrate, you have to do runs on a supercomputer.
Physics-based models are essentially very sophisticated math problems. They're based on observation and calculation of how energy and mass will all interact with each other to create weather. And in the world of atmospheric science, there was a belief that AI could never replace these kinds of models. In the 60s, a leading atmospheric scientist, Ed Lorenz, was interested in what computers could do when it came to weather forecasts. He was optimistic. He wrote a paper saying that based on an experiment, some kind of artificial intelligence or computer processing could forecast weather by a process called pattern matching. The only thing was, it would take so much data, it could not be done. It would take a, quote, miracle.
Now, how much data is a lot of data? In his paper, he basically said so much data that we currently don't have it. But later somebody, did some calculations and put a number on it, and it was 10 to 30 years of data.
Not 10 to 30 years, like, 25 years would be great. That's 10 to 30, like the 30th power. That much data. And that data truly doesn't exist because it is more years of data than the age of the universe.
That's a lot of data. We have 40 years of high quality data. We can, if you really look hard, you can get some older data, maybe 70, 80 years, but the quality goes down. But anyway, nobody has 10 to 30 years of data, right? So people after that paper sort of completely abandoned this idea of trying to do weather forecasting with pattern matching.
In 2012, there was a development in pattern matching. AI models started to do something pretty revolutionary. They could look at different pictures and tell you what they were pictures of.
Like they really became famous by going through Google Images and, separating cats from dogs and other things with incredible accuracy.
Literally cats and dogs. Ironic that this is also how we have to prove we're human on websites these days. But moving on. This is what pattern matching is. Being able to identify and label something correctly based on learning the pattern. So Pedram thought, okay, what if we try teaching the AI to tell us what we are looking at when it comes to weather, high pressure systems and low pressure systems? Maybe they didn't have miracle-level data, but it was worth a try.
Again, people tell us you don't have enough data, but why not just try and see? Maybe there's some stuff we can do.
He and others tested it out on hurricanes.
But then somehow we found that, no, actually it works. Even with 40 years of data, if you do it right, you can actually build weather models that can be better than any physics-based model that we have ever had. And so when we had our paper came out, the ForecastNet, and just a couple of days before that, somebody else also published a paper using a very different method, similar idea. So suddenly the community saw these two papers that actually showing that, you can get the track of the hurricanes better than anything we had before.
Pedram had just moved to the University of Chicago in 2024, and he wanted to use his AI skills and knowledge on something outside of what he normally did.
I was very interested in people in economics, policy, who, might be interested in this. And 2 or 3 people in my department mentioned Amir as somebody who understands weather and climate, who understands economics, who understands policy, who is doing amazing work.
In a lot of my other research, we show that so many decisions across society, particularly in the tropics and particularly in lower income countries, so many things that people do are affected by the weather and susceptible to then climate change.
This is Amir Jina. He's an assistant professor in the Harris School of Public Policy. He studies how climate change affects development in rich and poor countries.
So I sent him an email and said, hey, I'm new. I'm going to put together this proposal. Do you want to be a part of this? And he said, yes. And then he asked me to give a talk. And I thought I'm just talking to some students over lunch. I had a few slides and it was very informal. And I gave a talk, and it was mostly students. But then I saw this person sitting in the very back. He came to me and said, I'm Michael Kramer, and I'm very interested in this. And I was like, okay, many people say they are interested in something, and, they ask a few questions and leave.
Michael Kramer won the Nobel Prize in 2019 for his experimental approach to alleviating global poverty. He's also a professor at the University of Chicago.
He talked to me for 1 hour, and then there were emails. And I would say since that meeting, this has been the hardest I've ever worked in my life.
So much of the damage from climate change is going to happen through the types of economic errors that occur when somebody goes outside on a day that's too hot for them and starts working and might have an accident.
This is Amir again. He often works with Fiona Burlig, who you heard from at the top of the episode. And they're really interested in trying to help people adapt to climate change.
Or someone can't work as effectively as they want because it's a heat wave. Or a crop fails because you planted on the wrong day.
One way to help poor farmers adapt to climate change is by offering them insurance.
And unlike some other adaptation strategies we might think of, like insurance, for example, where you have to set up an insurance program and make sure that you have this actuarially fair system where people are paying into it and you can disperse well and you can track what losses are really well with inspectors and other things. Weather forecasts are, comparatively speaking, pretty cheap to produce.
Amir and Fiona looked at whether farmers would change their behaviors if they were given better monsoon forecasts. Ultimately, they did. They made better decisions, such as how much to plant, what to plant, or whether to plant at all. Amir, along with Pedram and Michael Kramer, decided to scale up that effort and make even better weather models, this time using Pedram's AI approach.
We didn't want to just test a weather forecast, or just any generic weather forecast. We wanted to think instead, what is the really big need that farmers would have?
It was information about the onset of the monsoon.
There are various forecasts for Indian monsoon, and some of them are commercial, some of them are free. But we went for 15-day and 30-day forecasts because there wasn't anything comparable with this. That's really what farmers can act on. And that builds on Amir's earlier paper with Fiona Burlig that actually they went to the field and found that, okay, this is the definition of the onset that actually matters to a farmer.
With the definition of the monsoon that farmers really cared about, Pedram dove into training an AI model. The models he started with are open source. The two that worked best at the end were Google's Neural GCM model and, get ready for it, it's a long name, the European Center for Medium Range Weather Forecasts Artificial Intelligence forecasting system, also known as AIFS. But first, he had to train them specifically to work for the Indian region. The way he explains it, it is kind of like working backwards. There aren't complex calculations involved. You're just showing the AI 2 pictures of a weather pattern, a before and an after. The AI's job is to look at millions of these before and after photos until it can start to predict from a random before picture what the after picture will look like. Training an AI model is a lot of checking its work.
So you start from the 3D field, you know that what happens 6 hours later, you ask the model to predict it 6 hours later, and you just want to make sure that you train the model, you just adjust these weights in the neural net to minimize the difference between what the model predicts and what actually happened. Yeah, so when we were developing these models, even when we found that these models have very good accuracy, even more accuracy, like they're more accurate than the best physics-based models, we thought, okay, the main advantage is that they're very cheap. But then when I talked to Amir and Michael, I realized, wow, okay, there's much more because these models are open source. So you can go inside the model and change it. If Michael says, hey, I really want to do a good forecast over India, I can build a model that's, best optimized for India, which is something you can also do with physics-based models. But then that needs really highly skilled workforce to do that, and a lot of time, and a lot of computing time, a lot of expertise to do that. Our focus has been on farmers, especially middle low-income countries where companies don't have incentives to actually develop forecasts for them because there's not a lot of money they can get out of it if they sell it, and then if they make it public when they don't make money. I mean, we are developing this, which I think is better than whatever is out there, free or not, but also it's all going to the farmers for free.
How the team is getting this cheap, reliable forecast to the developing world after the break.
Carry the Two is the show that pulls back the curtain to reveal the mathematical and the statistical gears that turn the world. Co-hosts Katie Witkowski and Ian Martin bring unique perspectives from the fields of mathematics and statistics to convey how mathematical research drives the world around us. With each episode tackling a different topic, subscribe to Carry the Two, part of the award-winning University of Chicago podcast network.
It's one thing to get the model working. It's another to actually get it to people. And that's the part of the project that happened this summer, seeing how people actually used it. This is one of the farmers in India who was part of the project. His name is Paris Natavari, a farmer based in a small village called Krishnagad. He's the 3rd generation in a long line of farmers before him and has been doing this for 20 years. We asked a journalist to go interview him about the experience. Ashrita Achar is also providing translation from Hindi.
The message reads as such. New weather information for farmers, received on the 18th of June 2025. There's a 50% chance of the monsoons arriving before 24th of June in your area.
This year's monsoon had a lot of rain.
I asked him if receiving these messages influenced his decisions of what crop to sow this year. He says that having received information of abundant monsoon this year in time, he was able to take the decision of choosing paddy. If not, he says he would have probably gone for wheat, black or green lentils, millets, crops that are less water intensive. He says that this messaging system helped him stay punctual and timely, whereas the other farmers that he's observed started the entire process a lot later than him. He says that the information he received was good.
He did share the information, though, too. So the forecast he got on his phone spread to others. Unpredictable weather has harmed his crops in the past.
Last year, due to the drought and a complete absence of rains after August, he saw that his crops had dried up. He also struggled to grow wheat in the next agricultural season. He says that it was a difficult year.
अब मौसम जब मार करेगा तो नुकसान होता ही होता है किसानों को प्रकृति सहारा है क्या करें
तो अभी ये forecasting आपके लिए helpful है लाभ है इसमें This is why he says that the weather forecasting messaging system has been beneficial.
मैसेज आ गया तो थोड़ा
Paris Natavari is the kind of farmer who relied on radio and TV for forecasts in the past. In his lifetime, he even just waited for the rain to start. So he liked getting a message. But there's even more information he would add to it.
अगला रिपोर्ट जरूर बताइएगा कि कब तक गिरेगा पानी अगली सूचना
He also says that it would be useful to know until when the monsoons would last that year. He says that this forecasting system could be much improved if known in advance about extended periods of monsoon, when would be the wettest and the driest days.
अच्छी सूचना दी जाए जैसे मैसेजिंग में आपके दबाव वहाँ है किसानों को दबाव तरीका बीज.
He also says that there is other information that he would like from a system like this. Information about new age farming techniques, as well as local access to the network of seed banks and fertilizers. At this point, he says that all the farmer does is rely on what's available in the market. But to also be equipped with this information themselves would be beneficial.
This is exactly the kind of feedback that Pedram and Amir are hoping to hear. We just got a sneak peek.
You know, it's not like somebody who does AI weather like me develops something and then hand it to Amir, and Amir hands it to Michael, and Michael and you know his colleagues just send it to a farmer. That's not the best way to do this. The right way is to have a feedback loop that people really have to work together, because when you want to do a benchmark, when you want to do a model development, there are so many things you can optimize for. There are so many ways you can define something. There are so many ways you can quantify the performance of the model. But this should be informed by actually what the stakeholder, what the downstream task would actually require.
That is another advantage of this specific project. Usually, technological advances are developed by companies like Google. Because they've made their technology open source, any weather forecaster can essentially apply it to their needs.
A lot of the effort on developing the AI models has been with large tech firms. And the reason you need that is because you needed GPUs, not CPU computing, which most places would have access to.
Basically, a GPU is just an advanced computer chip designed to handle many, many processes at once.
So companies making GPUs like NVIDIA wanted to think of an application for this. Just like the initial applications of the beginnings of computing being applied to weather forecasts, this application that people thought of was, let's look at weather forecasting. The people we talk to, they're very good atmospheric scientists, meteorologists who care about making sure that this works. The side benefit being, of course, it might work for business reasons and it might help demonstrate your technology working and other things. But it's lucky that we have an alignment of incentives.
Everyone is still figuring it out. We asked Pedram a very simple question, and the answer kind of blew our minds. Do we actually understand why the AI model is better?
No.
The AI is like an accurate fortune teller. It's proving very, very good at predicting the future. But it isn't obvious why it's better than the older physics-based models.
And I think that's something that people find scary. I see this as an amazing opportunity, for research and for questions we should be asking. But also, this question of, should we use a tool we do not understand? And, as a scientist, I think, that's a problem, but also does it mean that we shouldn't use it? But recently I gave a talk in my department, which is a very physicsy, very intellectual department. And I asked the question of, who knows how airplanes fly? Does everybody know why airplanes fly? And most people in the room raised their hand. And then I showed them this article in Scientific American talking to really one of the most famous aerodynamics people in the world, the guy who actually wrote a book that when I was an undergraduate student, that was like the textbook on aerodynamics. And the title was, we don't know how airplanes fly, because everything they teach you in college or high school, you cannot explain why airplanes can fly upside down. which you see all the time, like fighter jets can fly upside down. And those like things based on Bernoulli that, again, like, that the idea is that the air goes faster on the top of the airfoil. And so there's low pressure here, high pressure here, you get lift. That actually doesn't explain why these things can go upside down.
So Pedram is enthusiastic about the potential for AI to help adapt to climate change. Maybe even using an AI forecast will be as common as riding in an airplane. But he is not blind to how powerful and risky a new technology can be, especially when it comes to this project in India.
Yeah, I mean, so many times at 4 a.m., I'm not joking, I woke up and I was like, what happens if it's a major disaster? I mean, I know the models are not bad. I can see that, But how about if you made a mistake? And how about this year, it's a weird monsoon year? And it turned out to be a weird monsoon year, but also the models did so well.
It's an exciting time. The tools are advancing at a pace nobody thought possible.
AI weather forecasting is one of the biggest achievements of AI in science so far. I mean, again, there's protein folding. There are a few other examples, but I think in the realm of physical sciences, certainly weather climate, this has been a major achievement. I mean, weather forecasting has been something for the richest countries, for the most powerful countries in terms of science and technology, and now it's something that we can start democratizing it, provide weather forecasts to people around the world, and I think that's very exciting. In many sense, you can see this kind of providing weather forecasts, especially for farmers, as a climate adaptation strategy because, again, the historical information may not be as relevant as before. Food security becomes a more important issue. There could be more damages from extreme rainfall or from extreme heat. So better weather forecasts can really help a farmer, kind of protecting their investment and their work. So we see this kind of weather forecasting effort as a climate adaptation. It's not like a farmer in India, I think, can go to Google and for free get good weather forecasts.
I've spent a lot of time thinking about AI and climate. I had to talk to, who else? Michael Greenstone, about how much this has the potential to change humans' ability to thrive in a hotter world. So I've just had some really interesting conversations about how AI is going to help us better predict the weather. And I think for people like you and me, maybe that means we can plan our runs around the sunshine. But in a practical matter, in the United States, but in also lower income countries where, they're really dependent upon accurate forecasts to make sure that their crops can grow and not be flooded. So can you help me understand, how is something like weather forecasting actually a climate solution?
So there's this awesome word that in climate land called adaptation. And nobody really knows what it means. But everyone's like, we definitely need more of that. And with this work, Amir, Pedram, Michael, and Fiona, it takes that kind of poorly defined word adaptation and does something really productive with it, which is it has at its core the idea, hey, if people just knew what was coming, they would be able to take precautions or take advantage of opportunities. And that's absolutely going to be one way that all of us deal with climate change. And as you said, it might affect my life and your life in very mundane ways. But the worst parts of climate change, or the largest impacts, are projected to be in parts of the world that are pretty poor today and pretty hot, and especially bad in places that are poor and hot. And those are the kinds of places where you're not going to have like Google or someone else, or there's not a market. There's not a big market. So finding innovations that can help people better prepare themselves for the risks they face is just terrific work and super important. And the world's going to need 100 more of these kinds of discoveries.
So the word adaptation is a bit controversial to some in the climate community, not to get too in the weeds, but over time, there's been some concern that, if we focus on adapting to climate change, we'll just throw out the window this whole talk of actually reducing greenhouse gas emissions. So
I have no time for that viewpoint. There are actual human beings who are actually facing real weather and climate risks today. And the notion that somehow we should deprive them of the information or the interventions that would allow them to lead fuller, safer lives, because that might cause Lithuania or Pakistan or California or somebody else to emit a few extra tons of CO2. First, I don't even know if that's true, but like I find that a very, very challenged position to hold.
Mm-hmm. You know, the word adaptation, it reminds me of my Nordstrom manager back when I was just out of high school. And he would say, adapt and overcome, adapt and overcome. And back then I was worried about where the shirts were that we were trying to sell. But, you know, we kind of just have to adapt and overcome. Is that right, Michael?
I think we should look for opportunities to improve the well-being of human beings.
Adapt and overcome is much
nicer, yeah. And, you know, I am revealing I'm an academic and you're a journalist. Yes, adapt and overcome.
I'm here to keep you out of the weeds. So you mentioned something else about, you know, the likes of Google and all these big tech companies that do a lot of this management of the technology where we get our weather forecasts.
The broad point is companies build products where they can make money. And there's a mismatch there. And so we're going to need a lot of products and ideas that help people adapt to climate change. The mismatch is that the damages from climate change, the worst damages from climate change, are going to be in places where people are generally poor. And so we're going to need to find other ways that we're not going to be able to depend on the private sector in the same way to develop adaptation interventions. One example is there's some really recent research that's really interesting, which is like, you know, will they develop heat resistant seeds for the kinds of crops grown in poor places, or will they only, Monsanto and their like, only develop them in the rich countries where there's, you know, a very large market for the crops that come from those seeds?
So you're just saying that the current construct of capitalism doesn't really allow for Google and Meta and potentially other tech companies to make money from selling, for lack of a better word, this AI forecasting service to poor farmers.
I agree, but you made me a little nervous with the current construct of capitalism.
You know, I'm just spicing things up. I'm secretly planning to overthrow the world economic system.
Yes. I like markets. It's
Markets.
just that the market for these innovations might be kind of small. And a lot of the places where the damages from climate change will be the greatest.
So, you know, I remember earlier on, probably around 2010, when this whole idea of climate adaptation was almost like a third rail issue. Politicians wouldn't talk about it. And it was like, oh, no, we can only focus on reducing emissions. We can't even touch the topic of adaptation. Why was that? Are you still seeing that today?
So, as I said, I really have no time for that argument, but I do think what is really interesting, what you're getting at, is that argument has less traction than it did. And I think that's a reflection that the emissions just keep churning out. We're doing about 50 billion tons of CO2 equivalent per year. That's going up. Maybe it's about to flatten out, but it's been going up systematically for many decades. And the time for like a prissiness of we have to confront climate change while, like, if you remember in The Cat in the Hat, standing on a ball, spinning a plate on one finger, wearing a top hat, and juggling with the other hand, like, we don't have time for that anymore. Climate change is here. I think it's really interesting that there is less of that, and I think it just reflects climate change is here, and there's an acceptance of like 1.5. Nobody's talking there.
When you say 1.5, what do you mean? You don't mean like...
So that was an idea that we should...
1.5 degrees.
Yeah, that we should
Celsius.
limit climate change.
Which means nothing to most Americans, unfortunately. We're long past that.
I think the idea that we can't adapt because it might encourage people to emit more was part and parcel of an era when we thought we were going to limit the warming to something like 1.5 C, which, due to my handy-dandy calculator, we know is 2.7 degrees F. And that was like a myopic era of climate change. That era is over. We might even be, we're not sure, but we might even be over 1.5 now. And I think we've moved on from that. Climate change has got to be, as I was saying, handled in the super amazing cat in the hat, bouncing on the ball, spinning the plates way, to all hands on deck. We just got to limit damages. We got to limit the amount of climate change, and we got to limit the damages. And we can't get worried about the second order concerns.
But what do you say to the people who are worried and have been concerned that this focus on adaptation is starting to supplant efforts to reduce emissions, particularly at a time when we have a Republican administration in the United States that's rolling back most climate policies aimed at reducing emissions?
I think we should walk and chew bubblegum at the same time. And what I would say to those people is, but people are suffering now, and we have to do something about that. It's not okay.
I did grow up on a cattle ranch, and my family still has the ranch. And I will say I'm the least informed of my whole family about the ranch. So please don't quiz me.
Do you have like a big belt buckle?
I did have a pony for about 15 days, and I never rode it, so my mom gave it away.
Oh.
My sister had a pony, and she rode her pony a lot. And her pony was named Death Trap.
Was it a well-deserved name?
It was. It was a very dangerous pony.
Okay.
I kind of rebelled and have not been as connected to the ranch roots. So my family is a cow, and I'm part owner in the land. And I've written about, and I disclose this whenever I write about climate, the beef's impact on climate. But, you know, I obviously know about the ranch. And one year, there was a late extreme frost, and 3 or 4 cows died. And that's $3,000 or $4,000, poof, gone.
Out of how many?
Well, here's a fun fact, Michael. Asking somebody how many cows they have is like asking them how much money they make.
Oh, is that true?
It's considered improper. Yeah.
Oh.
Yeah. Also, same thing if you ask how much land somebody has. Yeah. Seriously.
So but that's really important because
we have more than a dozen, but less than 1,000.
Okay. Because I definitely, there's a distinct possibility I'm going to become a cowboy.
Mm-hmm. Okay.
And so that's super useful information.
We lost 3 cows, and that's, a lot of money. And so had we been able to predict that, and I don't know enough about, this new technology to really know if that we'll be able to predict it right now. I mean, I know we've been focusing on floods and whatnot, but to me, I mean, that is dollars and cents, and it's really important. And so
if there was a technology that would have prevented those cows from dying, you guys would have been thrilled.
Yeah. And I mean, don't get me started on water. There's a shortage of water where our ranch is, and knowing how to maximize the water would be incredible. I think a lot of casual users of AI, I mean, they're using it for their vacation plans or to make up silly lyrics. And okay, that's funny, but this is incredible. This is going to improve lives in the places we need it most.
It is going to improve lives in the places we need it most. And so we need I view this as we're just starting to open the book of what might be possible.
So how do you consider this adaptation when we're not building a seawall or a cooling center?
Yeah, so I think what's remarkable about this project is that it illustrates that, it confirms people are amazing at figuring out solutions to problems they face. They can't solve every problem, but they can't do it if they don't have the information about the nature of the problem they face. And so I think a very powerful form of climate adaptation that we're seeing here, and that I suspect will snowball, is giving people the information they need, in this case, when the monsoon is going to arrive and how that should influence their planting decisions. But people can't undertake those adaptations if they don't know what's happening.
It will help them adapt and overcome.
It will help them adapt and overcome.
Shocked is part of the University of Chicago Podcast Network. It was produced by Jesse Baker and Eric Nuzum of Magnificent Noise. Our production staff includes Christine Driscoll, Amy Pedulla, Sophie Bridges, Jamie York, and Samantha Henig. Our sound designer is Kristen Mueller. A big thanks to my co-host, Michael Greenstone, a professor at the University of Chicago and director of the Institute for Climate and Sustainable Growth. He also serves as executive producer of Shocked, along with Sam Ori, the executive director of the Institute for Climate and Sustainable Growth. The Institute combines a 360-degree approach to education with frontier research having an impact in frontline communities globally. The Institute's efforts are driven by the need to balance climate risks with societal growth. To follow or support their work, see our show notes or visit climate.uchicago.edu. For more of my reporting, you can look for me on pretty much any social media. Search Amy Harder, or look for my byline at Axios. This is Shocked. I'm your host, Amy Harder. Thanks for listening.